Hi everyone, another video. Today we'll be going over how to constrain element force for MSC Nastran. The idea here is that you're performing a transient analysis with MSC Nastran and you want to maybe modify a design parameter of your model. In this case, we're modifying the spring of this 1 degree of freedom system. Here in this graph, I have the original force plot over time for the force in the spring. You can see that we have a minimum spring force of about negative 200 newtons. So that would be in compression. Right now, the question I'm looking to answer in this video is, what value of the stiffness, or K, will give me a minimum spring force of negative 250 newtons? So basically, I'm asking, how soft can I make the springs so I have a compression load of no more than 250 newtons, and we'll be using the Nastran optimization capability to answer this question. As always, if you have any questions, comments, feel free to send me an email at this email address here. I'd be more than glad to train you, mentor you, offer guidance, give you access to the web app that makes it possible to perform optimization. And today, or rather here on this slide, feel free to pause the video and carefully look at the description of the model. As for our optimization problem statement, I'm looking to minimize the cost of the spring. My design variable will be the K value of the spring, so the stiffness of the spring. As for my design constraint, I'm going to impose a design constraint on the element force. What I'm going to say is, the element force in the spring should be no less than negative 250 newtons. So now let's go ahead and jump into our web app and discuss what the process is. I've already taken time to create our design variables, our objective and constraint. So that would be this PDF file, my design variable, and my constraints. Let's go ahead and delete that and recreate these constraints. Design variables, my objective, those are already in here. And now let's go ahead and walk you through the process of creating a constraint on element force. So let's switch the analysis type to modal transient response. And we'll go ahead and scroll through the list until we find element force. Click on this element force icon one time to create your element force. For our property type, we're going to type in pbush. This is the property type that was used to define the property of the element. So here you can see pbush. As for the force item code, this is where we'll need the MSC Nastran Quick Reference Guide. There's a chapter 6 called Item Codes. If you go to the section for cbush, this gives us the necessary item code to use for this optimization. What we're looking to do is find the component that corresponds to the X component of the element. And right now I made the mistake of selecting the element stress section of chapter 6. What I should have selected is element force item codes. So here, once you're there, scroll through cbush, and here you see it says the force in the X direction corresponds to item code 2. So let's go back to my virtual machine and type in a 2 there. And then for the time value, I think we are saying the minimum. Yes, we're constraining the minimum. So we'll type in min here. And for property ID, this would be just the corresponding pbush ID that we've created for the spring. So it'd be a value of 1. And for the minimum, we're saying it can be no less than 250 newtons. And now here on the right is my new output I can use. Let's copy that to my MSC Nastran model. We'll go ahead and paste it here. We'll save the model. And now we're done defining our constraint in the Nastran BDF file. So what I can do now is go to the folder and perform the optimization with this new constraint. And while that's happening, again, If you want more training, if you want me to walk you step by step through this example or any other example I've done, my email address is here. Definitely feel free to reach out. And now let's go ahead and open our F06 file, and we'll inspect the bottom portion of the file just to make sure our optimization went successfully. And here I can see that it did. Let me look at the objective values real quick just to make sure these are the ones I plan to receive at the end. Okay, perfect. So as planned, I did get the results I wanted. So now let's go ahead and discuss the results. So initial cost of the spring was $10, and now the cost is now $4.72. A spring was 2,000 newtons per meter, and now it's 945 newtons per meter. Here in orange is the time history of the spring force over time. And you can see previously it was at a minimum compression value of negative 200 newtons. But now with the new spring or the final design, my minimum spring force is negative 250 newtons, which is the design constraint we imposed at the very beginning. These values of 4.72 and 945, these were obtained from the F06 file. So the 472 was the final value in column 3, the objective from exact analysis. That's where I obtained this value. And as for the design variable of 945, this is located in the design variable history. So you see that we had approximately 6 design cycles here before I finally found the optimum. So here in the last design cycle, we had a value of 945 Newton meter. So that would be the value here on the right. And so that's basically the process of imposing a design constraint on element forces. As always, if you have any questions, comments, feedback, feel free to email me. And thank you for watching.